Alright folks, let's get started with this live stream. I want to just start. I am transitioning into a different textbook, just because I find this new textbook is a little more friendly to what we want to get into in the next little bit here. So just to quickly go over the differences and some of the features that it has that I kind of like. Each section, when you get to the textbook portion, will have a learning goals that'll kind of give you, these are the things that you should be understanding, so that's useful. It's got a nice, all the key terms are nicely laid out in the sides, which is pretty standard. But as you go through, there are some, on top of the questions, so this isn't part of the normal questions that I'm assigning as practice problems, but as you go through, after you've done and taken a look at examples or listened to the lesson online, this should show you know section is pretty useful in that it has some key ideas. So if you really want to check and see, do I understand this content, check these show you know sections. There's one or two in each for each topic. These will really, if you try these questions, check the answers in the included answer set. That'll help you really get a good justification as to, you know, I'm getting it, yes, I know it, I'm good, or, you know what, I need to do a little bit more work, and maybe ask for some help. So check those out. I think those are really useful along the way. And then again, there might be mixed questions within there, and then there's here, this one has a second show you know, and then another example, and yet a third show you know, so this one even has three. And then it goes over and consolidates those key ideas, and then the questions themselves will start in the apply section. And so that should kind of get you through the different areas of the book. Also, any of these questions here that have an A, B, and C, which are in capital letters, those are multiple choice questions. So that should again be useful as well. So that's the kind of overview of the textbook transition that we're doing here. So today's topic is equivalent ratios. Sorry if I can get this transition right. There we go. So equivalent ratios. And when we're talking in terms of ratio, it's probably something that you've seen and probably used at times, but you might not really have connected it with the math behind it. So something like, you know, you're mixing frozen, one of those frozen cans of lemonade, and it says that you want 1 can lemonade to 4 cans of water. So something like that is a ratio. It's comparing two things in the same units. So how much of the lemonade and how much in cans and how much of the water in cans. So note that these are the same units. We're measuring in cans. So we're not measuring 1 cup of water to 5 gallons of lemonade. We're using the same set of units when we're doing these comparisons with ratios, so it's important to remember that when you're working with them. Oftentimes, we will write a ratio out like this. So this reads as 1 to 4. Okay, so that semicolon, or sorry, that colon in the middle, that means 2, and that's a comparison. You might see this sometimes in terms of gambling. If you look at a like a craps table or a roulette table, oftentimes you'll see the payoffs. You know, if you're betting on red black on a craps table, you might see that, you know, you pretty much, you don't exactly have, but you pretty much have a 50-50 chance. So it'll pay you 2 to 1. So if you bet $1, they'll pay you 2. That's what that means. In case of you know, the gambling and things like that. So we often see it in things like that. You know, sometimes for fights and sports matches and things, sometimes they'll give the odds this way as well. There are other ways of giving out odds, but we're using a ratio like this is a standard way. And then just note what you're comparing in different times. Sometimes you're comparing the part, or sometimes you're comparing the whole. So in the case of our lemonade here, this is 1 part to 4 parts. So there's a total of 5 parts. There's 5 cans of liquid that are all mixed together. One of them is lemonade, one of them is the water. But sometimes you might compare that to the total. So you want 1 can of lemonade to the whole 5 total cans, and so you do a 1:5 ratio. So you got to be careful when you're reading those. A lot of times we will stick with the part-to-part comparison when we're talking about ratios. Now, more specifically, what we're focused on here is equivalent ratios, and that means we're kind of comparing ratios to each other. And so this is not unlike comparing fractions and finding equivalent fractions. When we do that, we kind of get a common denominators and things like that, working with those concepts of common multiples, common denominators, common factors. These things are all kind of related to working with our ratios. So this here, because we can compare ratios to fractions and write them in fraction type formats too, it's a good, it's fairly easy transition hopefully as we're working with this. So let's take a look at some of the problems that I had assigned there. They were 1, 2, 4, 6, 7, 9, and 10. And so we'll look at a couple of those and see how we make out. So just communicating in terms of ratios. If we look at question number 1 here, a baseball league has 60 switch hitters, 60 switch hitters, 180 right-handed batters, and 120 left-handed batters. So switch hitters meaning that they can hit left or right-handed, and then 180 are exclusively right-handed, and 120 bat exclusively left-handed. And so we have a series of ratios that we want to write in the lowest terms. So if we look at the case of right-handed to left-handed batters, then we have 180 right-handed batters to 120 left-handed batters. Now that is not in lowest terms. If we take a look at this, the ratio here, 180 to 120, that can be simplified. Now you might do this in one step and realize right away that there's a common factor in between these two, or you might take a little bit of time and go step by step and figure it out as well. If you look at it step by step, say you were to try this one and you looked and said, okay, 180 to 120, how do I simplify that? What's the biggest number that divides into both? Well, right away, I see that they end in a 0, so I know both are divisible by 10. So we're going to divide both of those by 10. And 180 is divided by 10 is 18. 120 divided by 10 is 12. So I've simplified it a bit, but I look at 18 and 12, and I know those aren't simplified either. This can get even smaller. There's numbers that divide into both of these. 18 and 12 both have a common factor of 6. So we can divide out 6. That's the common factor. And if we divide both of those by 6, I'm going to get 3 to 2. Now 3 and 2, those are prime numbers. I can't divide those by anything, so that would be simplified written in lowest terms. So here is our solution then. So I'm just dividing by a number that divides into both terms along the way until I get it down until I can't divide by anything else. If you right away recognize that the common factor was 60, you could go right from here to here. If you don't, you may have to pay attention along the way. It may take a couple steps to find it as you work your way down. If I continue writing some of these ratios out, we had the next one was left-handed batters to switch hitters. So there was 120 left-handed batters and there was 60 switch hitters. And it's important to write these in the proper order. It does say in the question here, left-handed batters to switch hitters. So that means left-handed batters have to come first and switch hitters have to come second. Okay, so left-handed batters to switch hitters, you have to do it in that order. And so that's where our 120 to 80 is there. And then if I simplify that, both of these, well, 60 goes into both of these numbers actually. So I'm going to divide both of these by 60, and I'm going to get myself 2 to 1. And then you'd continue on comparing right-handed batters to total batters. So this one here, we got to pay attention that we're not given explicitly total batters. We have to actually add that up. So we had 180 right-handed batters, but when we're comparing 180 to the total number of batters, in this case here, we got 180 plus 120 plus 60. And so if we add all those up, we're going to get 360. So there's a total of 360 batters. And so righties to total is 180 to 360. And in this case here, again, both of these numbers going to be divisible by 60. So let's try that. So 180 divided by 60 is going to give me 3. And 360 divided by 60 is going to give me 6. Well, 3 and 6, that's not simplest terms because 3 goes into both of those numbers as well, so I can simplify that a little more. Divide both of those by 3, and I get 1 to 2. And then the final comparison was total players to left-handed batters. So now it's important to look at this, that we said total players first. So we have to write down the 360 first. The total number of players in relation to the left-handed batters, which was the 120 we had used in the previous questions. So we flip that around, and in this case here, I can see right away 120 is going to be a common factor between these two, and so I can divide both by 120. I'm going to be left with 3 to 1 as my ratio. So the total number of batters to the left-handed batters, there's a ratio of 3 to 1. So that means for out of every 3 batters that are out there, one of them is left-handed. In this case here, right-handed batters to total, for every right-handed batter in the league, there are 2 in total. In this case here, for every left-handed batter, or so every 2 left-handed batters, there's 1 switch hitter. So that's how those ratios are looked at and kind of read. You could also write these as fractions, and so you could have 3 over 2 and 1 over 2 in that. But I'm going to try and get this notation a little bit with you guys. So number 2 here had asked, state whether each ratio in number 1 is a part-to-part ratio or a part-to-whole ratio, and then justify our answer. So is it part-to-part or part-to-whole? Well, the whole was the total. That was that 360. So only those 2 that include the total number of hitters in the league, that's going to be our part-to-whole. So for number 2, A and B are part-to-part. They look at some of the players on both sides. So on both sides of these, they're looking at some of the players, and then C and D are part to whole, as they look all of the players on one side. So they look at all the players on one side. We're comparing all the players on one of those sides. So these are part to wholes, these are part to parts. So that's kind of the general gist of setting them up, writing equations in some situations there. Another good one here maybe to take a look at is number 6. So I'm going to switch over here, and then I'll scroll down to number 6. So number 6 is a multiple choice question. It says, Emma makes bronze jewelry. Bronze is a mixture of copper and tin in a ratio of 22 to 3. So our copper to tin ratio is 22 to 3. And Emma has 88 kilograms of copper. How much tin does she need? Well, let's actually do the math behind this. So copper to tin ratio is 22 to 3, and she has 88 kilograms of copper. We need to find out how much tin she needs. So that's the missing value there. So what I would do here is start with the copper, and to go, we're going from 22 up to 88. So we're going this way. We need to multiply 22 by something. And there's a couple ways you can do this. You can recognize maybe right away that you see, well, okay, we just multiply this by 4. But if you don't see that relationship right away, what you can do is kind of some scratch work on the side here. We take 88 divided by 22, and that's going to give us our value of 4. Okay, so that's the multiple that works between those. Since we're increasing, we're going to multiply by 4. So we're going to multiply 22 by 4, and that's going to give us 88. Thus, we need to multiply 3 by 4 to get the equivalent ratio. So 3 times 4 is 12. So we need 12 kilograms of tin, or Emma, sorry. Emma needs 12 kilograms of tin to get her total amount there. So what we did again is that we're looking at the relationship between the two values in the same place. These were both in the first place. Copper, this was both a value of copper, so this is the value of our tin, the amount of tin that we were missing, and that's how we found it. Number 7, what else? Number 7, number 9, and number 10. Let's look at number 9. I like number 9 there. An explanation type of question. So let's scroll down to number 9. In number 9, it says, to make 10 cups of caramel popcorn, a recipe calls for 2 cups of peanuts and the rest popcorn. Jeremy says the ratio of peanuts to popcorn is 2 to 10, which he can reduce to 1 to 5. Is he correct? So let's look at this. We want 10 total cups of popcorn. And the recipe calls for 2 cups of peanuts and the rest popcorn. So are we looking at a part-to-part or a part-to-whole situation is what we need to look at. Is that if we have 10 cups of caramel popcorn made up of 2 cups of peanuts and the rest popcorn, that means that the ratio of peanuts to popcorn is not 2 to 10. That is a part to whole. The whole is 10, the part is 2. So we actually need a part to part. So in this case here, what we would have is that 2 to 10, this was number 9, right? Yeah, number 9. So this is peanuts, I'll use PN for peanut, and PC for popcorn mix. So that's the total mixture. The actual peanuts to popcorn, well, we had 2 cups of peanuts and the rest was popcorn. So that means the rest is only 8. So that's the ratio that he was looking for, and that would be equivalent to 1 to 4. So in the case of Jerome there, if he's trying to reduce the size of that, maybe he doesn't want to make a full 10 cups of caramel popcorn, maybe only wants 5 cups, then he needs to reduce. This ratio here is a total of, he's looking for 12 cups if he thinks it's that. So this here, make sure that we only have the total of 10 cups of the popcorn mixture the 2 peanuts and the 8 cups of popcorn. So that is kind of how that one works out. And then number 10. So in number 10, we have Braden plays in a softball league. Last season, his batting average was 0.375. Batting average compares the number of hits to the number of turns at bat. So batting average is an interesting one, and I picked this one because it's a little bit different. While he was at bat for less, he hit less than one time, is what that kind of looks like. But it's not. It's read funny. Batting average is actually written out of 1,000. So 0.375 here means that we have 375 out of 1,000. So for every 1,000 times he would have went to bat, he would have hit 3.75 times, or 375 times. That's how the batting average is actually read. So if we want to do it said in A and convert that to a ratio, well then it's 375 to 1,000. So when you ever hear someone talking about baseball and they're like, oh, the batting average was, he's batting 500, which is really good. If you're that means you're hitting 500 times out of 1,000, or 1 out of every 2 times. That's pretty good in baseball. So in this case, he's getting 3.75 out of 1,000 times at bat. And if we want to simplify that down, then we need to find a common factor for both of those. 75. Looking at the 375, I know it's going to be divisible by 25. So I'm going to start with 25. I'm going to divide both of these by 25, see where that leads me. And so 375 divided by 25 first is 15. Pencil here. So 15, and then 1,000 divided by 25 is going to give me 40. So that's getting better, but both of those are divisible by 5. So let's divide both of those by 5, and 15 divided by 5 is going to be 3. 40 divided by 5 is going to be 8. So that's the simplified value that we were looking for in part B. So what's that mean? Well, that means that every time Braden went up to bat, or every 8 times Braden went up to bat, he hit the ball 3 of those times. So that would be that value simplified. But again, in baseball, they like to use this decimal out of 1,000 to represent, and this is a way that we can convert that. So we were out of 375 out of 1,000, and thus 375 to 1,000 would be our ratio, and then that simplified down to 3 to 8. All right, so that is a little bit of an overview of some equivalent ratios. We have some rates and proportions coming up in the next couple sections, and after that we will move into some linear relations. So if you have questions along the way, make sure you are asking them. You can send me messages via Edsby, or you can send me messages via email, and I will respond in between. Or if you can't make the live stream but you want me to take up a specific question that you've been looking at, send me a message before any scheduled live stream, and I will add that one in as well. Other than that, that's about it for today, so you guys have a good day.